Hello, men and women of science. This is Mr. Cochrane here to talk about stoichiometry. And in this video, we're going to kick it up a notch and talk about calculations involving mass in chemical reactions. And that's usually measured in grams. So here we go. Remember from our last video that all stoichiometry starts with a balanced chemical equation. This is the equation for the formation of rust from iron and oxygen. You'll notice, however, that it's not balanced. On the product side, I have 3 oxygen, and on the reactant side, I only have 2. 2 and 3 both go into 6, and so we can put a coefficient of 3 in front of the oxygen on the reactant side and a 2 in front of the iron 3 oxide on the product side, and that gives us 4 iron on the product side, so we can fix that by putting a coefficient of 4 on the reactant side, and now we have our balanced chemical equation. These coefficients, 4, 3, and 2, tell us how many moles of each substance are involved in the chemical reaction, but not grams. So to do stoichiometry with gram to mole conversions, then we are going to start with a balanced equation. We're going to use mole ratios from that balanced equation, but we also have to use molar mass to convert from grams to moles or moles to grams to be able to use those mole to mole ratios. So let's get started. What is a mole ratio? Well, we talked about that in the last video. These coefficients, 4, 3, and 2, tell us that 4 moles of iron react with 3 moles of oxygen to produce 2 moles of iron 3 oxide. From that, we can derive several mole-to-mole ratios in many different combinations. For example, we could have 3 moles of oxygen for every 4 moles of iron, and we could have 4 moles of iron for every 2 moles of iron 3 oxide. The mole ratio that we would use would be determined by what we're converting from and converting to. So let's get started. To use that mole ratio, we're going to have to be able to convert from grams to moles using molar mass, or moles to grams using molar mass. Molar mass is the mass of 1 mole of a substance. 1 mole of O2 has a mass of 2 times 16 grams of O, or 32 grams of O. Remember, you can find these numbers on your periodic table. The molar mass of something is the atomic mass in grams. So that gives us a couple of conversion factors: 1 mole of oxygen for every 32 grams of oxygen, or 32 grams of oxygen per mole of oxygen. We would use the first ratio to convert from grams of O2 to moles of O2, and we would use the second mole ratio to convert from moles of O2 to grams of O2. Another example of using molar mass from this equation involves iron 3 oxide. Iron 3 oxide has 2 moles of iron and 3 moles of oxygen, so we would multiply the atomic mass of iron by 2 and the atomic mass of oxygen by 3 in grams. That would give us moles, and that adds up to 159.7 grams per mole. And so that again can give us 2 conversion factors. The first one would be used to convert from grams of iron 3 oxide to moles of iron 3 oxide, and the second to convert from moles of iron 3 oxide to grams of iron 3 oxide. The situation would depend on the problem, so let's try a gram to mole problem. This question asks how many moles of iron metal are needed to react with 5.5 grams of O2. And again, to solve this problem, we need a balanced chemical equation, and there it is. It's useful to identify what you're converting from, in this case 5.5 grams of O2, and what you're converting to. They are asking us to find moles of iron metal. To start a stoichiometry problem, you should write down what you have to begin with. Be sure to include both the unit and the substance involved. And students, again, who have difficulty with Stoich, forget to do that. So make sure you write those down as you start your problem. Now, our equation is written in terms of moles. So in order to access our mole ratio from the equation, our first job is to convert from grams of O2 to moles of O2 using the molar mass of O2. That's the grams per 1 mole of O2. And now that we have moles of oxygen, we can use our mole to mole ratio from the equation. In the equation, there are 3 moles of oxygen for every 4 moles of iron metal. And since that's our desired unit, we can grab a calculator and do the math. Remember to multiply by any numbers on top and divide by any numbers on bottom. And if you do the math and round to 2 significant figures like our starting value, you'll find that there are 0.23 moles of iron required to react with 5.5 grams of O2. So there's our first stoichiometry problem. Now let's kick it up another notch and do a gram to gram problem. This question asks how many grams of iron metal are needed to produce 62.5 grams of iron 3 oxide. We're going to start with our balanced chemical equation again. Identify our starting value, 62.5 grams of iron 3 oxide. This time our desired value isn't moles, it's grams of iron. So let's begin. We're going to write down our starting value, what we're converting from. We've included both the unit and the substance. And since it's grams and we want to use the mole ratio from the equation, we have to use molar mass to convert from grams to moles. Grams of iron 3 oxide factor out when we set it up this way. And now we have moles of iron 3 oxide. We can now use the mole-to-mole ratio of iron to iron 3 oxide, and you'll see in the equation, for every 2 moles of iron 3 oxide, we have 4 moles of iron. And the reason we chose moles of iron here is we're trying to get to grams of iron. Moles of iron 3 oxide factor out, but we are in moles of iron still, and we need to get grams, so it's time to go back to molar mass. The molar mass of iron is 55.85 grams per mole. You'll notice we put grams on top and moles on bottom this time so that moles of iron factor out. And we're left with grams of iron, which is our desired unit. And we can grab our calculator and we can start crunching some numbers. Multiplying by numbers on top, dividing by numbers on bottom, gives us a mass of 43.7 grams of iron. That's rounded to 3 significant figures because our starting value has 3 significant figures also. So to solve a stoichiometry problem with grams, you're going to start with the balanced chemical equation. You're going to write down our initial value that we're converting from with the unit and the substance. If that initial value is in grams, we can use molar mass to convert it to moles, but we don't need that if it's already in moles. We're going to then use the mole ratio from the balanced chemical equation to factor out our initial mole value and give us our desired moles. If we want our final answer in grams, we're going to use the molar mass to convert from moles back to grams again. Then you can grab a calculator, crunch the numbers, and round to the appropriate significant figures, and then circle your answer. So go ahead and pause the video in a moment and try these practice problems below. Copy them into your notebooks. Show all the work with the units factoring out. And in a moment you can play the video again and see if you get the correct answers. So pause the video now and give it a try. So here's the answers to the questions that you just worked on, rounded to the correct significant figures. If you're not getting the correct answers, go back and look at the video again and see if you may have made some errors somewhere. If you're still having difficulty, bring your work in to share with your teacher and we'll see if we can't fix the problem for you. Thanks for watching this video. I hope it helped. This is Mr. Cochrane signing off.